Hey there. Ever wondered how your phone or a robot sees the world in 3D? Today, we're unpacking a breakthrough in 3D object detection, how computers can reconstruct 3D scenes from just 2D photos. Let's dive into the research from Zhejiang University that's redefining how machines perceive space. 3D object detection is the art of teaching machines to see in 3 dimensions. Traditional methods rely on expensive sensors like LiDAR to map environments, but what if we could do this with just a camera? That's where SGCDet steps in, a revolutionary approach that transforms 2D images into 3D understanding. The challenge: combining data from multiple camera views. Imagine looking at a room from different angles. Each photo captures fragments of objects, but stitching them into a coherent 3D model is no easy task. Earlier systems either missed critical context or wasted resources on empty space, like filling a cake pan with batter for a room that's mostly air. SGCDet solves this with adaptive 3D volume construction. Think of a 3D grid, a voxel grid, as a digital cube cake. Each voxel, a 3D pixel, needs to know if it contains an object. Traditional methods filled every voxel, regardless of content. SGCDet, however, focuses only on the important bits, optimizing both speed and efficiency. Here is how it works: 2 core innovations. First, a geometry and context-aware module. This isn't just about locating objects, it's about understanding their spatial relationships. For example, it recognizes a chair's legs and the floor they rest on, capturing both form and context. Second, a sparse volume strategy. Instead of refining every voxel, it prioritizes those most likely to hold objects, eliminating unnecessary computations. The team also tackled a major hurdle: reliance on perfect 3D data. Previous systems needed precise geometry, which is hard to obtain. SGCDet uses only 3D bounding boxes, essentially 3D outlines of objects, to train, making it practical for real-world applications. The results: SGCDet outperforms state-of-the-art methods on datasets like ScanNet. It's faster, uses less memory, and even surpasses systems that rely on perfect 3D data. Imagine a robot navigating a room with just a few cameras. This is how it could begin to truly perceive its environment. So what's next? This tech could transform augmented reality, robotics, and autonomous vehicles. By making 3D perception smarter and more efficient, we're inching closer to machines that understand their surroundings as intuitively as humans do.